So thanks for having me. My name is Ryan Sciampacone. I'm from IBM, Java Technology Center specifically. I work with Dan, who did the method handle introspection talk yesterday. And, well, today I'm here to talk to you about the multi-tenant JVM. Legal. That wasn't meant to be funny. So what am I actually going to be talking about today? All right. And what I want to do is I want to look at the technical challenges that we've experienced while trying to get multi-tenant support plugged into the Java runtime, specifically the Java VM, although this affects the JDK platform as a whole. And what I want to do is really kind of look at some of the building blocks associated with that, and not necessarily some of the problems that we solve, although these problems are important, but rather how existing problems end up getting changed a little bit, not necessarily solved or eliminated, but changed, and how new problems end up coming to the fore. Now, by way of to explain my perspective on things, my background, excuse me, is I've spent about 10 to 15 years, give or take, in garbage collection, and just recently I've actually moved to being JVM, core JVM guys, so that includes the interpreter, platform support, interface, and so on, along with the garbage collector. So my perspective is very much from the runtime point of view, and less so from the language point of view. So based on that explanation, if you weren't thinking this when you saw the title of the talk, I'm willing to bet you're definitely thinking this now. There have been a few talks that have been a little bit reachy in terms of on being on topic for this conference. And the way I want to frame it for everybody here in this room, there's a lot of really smart people in this room that are busy building either language infrastructure, runtimes, or really low level core infrastructure type items. And what I want to frame this here as for everybody in the room is this kind of thing is coming. Right? Now, not necessarily the thing that I'm talking about, but this in general in multi-tenancy is coming in some form, right? Everybody seems to be thinking about it more and more. And this is just our perspective on things, what we've gotten to so far. It's a point-in-time statement. And when you're actually building your low-level core items, if anything, I hope that you walk away with the thought that, okay, this is actually important. I need to think about these things. All right, I don't know that I'm necessarily going to educate anybody here. There isn't a lot of new things, but hopefully I can get you to really think about it and go, yeah, okay, this is actually important. I really need to think about this when I'm building my software, my runtimes, my languages, and how this might fit in. Right? One of the big problems that we've got here with Java is that we've already got this existing ecosystem, this existing runtime, existing language spec, and then you're trying to fit something kind of really, something difficult into the language. So what, a few charts to sort of cover the basics and so on. What is multi-tenancy? What are we talking about here specifically? Well, if you look at the first two paragraphs, it's really about taking one instance of a piece of software, like just taking, literally one instance of it and running multiple, we'll say copies, but really, you want to run basically, you want to have a runtime system that is able to support multiple versions of state, but just a single copy of the actual runtime. This is in contrast of actually creating multiple copies of the runtime, or the runtime components, and running it that way. Now, if you want to kind of look at it in overly simplistic terms, this is literally like saying I'm going to take a jar file, and I'm going to load this once. I'm going to effectively instantiate everything about that thing once, but then I'm going to have just very minimal amounts of state running multiple times on top of that, versus actually taking a single jar file and loading it multiple times, potentially on multiple JVMs, and running a single, running state for each individual copy of those things. Now, this definition is a little bit funny, and that's kind of an overly simplistic view. And this definition here has a few problems with it, though. I mean, that sounds great, what I've just talked about, but there are a few problems. In particular with the third paragraph, the word designed in the first sentence is actually really, really difficult, right? So when you talk about this, you think, hey, this is a great idea, right? Or maybe it's a great idea. We'll find out that it's a great idea. But as soon as you see the word designed, client organization works with customized virtual application instance, that's really, really scary, right? Nobody wants to rewrite their code to use things. Nobody wants to change things to use stuff. There's a lot of existing software out there. People just want to plunk stuff down and gain the benefits of the runtime system, whatever it's providing, right? You've got a whole bunch of Java code. You don't want to go out there and go, yeah, okay, you need to change this, that, and the other thing to get it to go. The perfect example of this is the real-time specification for Java. There's plenty of people, and I've actually worked on that, so I'm not trying to be overly critical. But one of the issues, and I'm not going to comment as to how good it was, but one of the big issues was that customers would show up and say, hey, this is exactly what we want. Sounds like it, at least anyways. The moment that you said, oh yes, but you have to basically rewrite all your software to take advantage of it, customers would just walk away, right? So you want this to be fairly lightweight. So that's sort of the high-level view of what I'm talking about. But what am I actually trying to achieve here with multi-tenancy? And from a working definition, it's really just it's a single instance of software application that serves multiple customers, and each of those customers is a tenant. So what you want is as much non-duplication as possible, and at the last possible point, which is typically just state or configuration or so on, that's where you end up having duplication or multiple copies. But beyond that, you want to be sharing as much as humanly possible or machinely possible. Right? And that's really the second point, is that's fine. You want to share a whole bunch, but really state and so on. These are the things that you actually want to you want to allow each of these customers to be able to customize, change, and so on. But that's about it, right? That's really about it. And finally, and I alluded to this earlier, you don't want this to cost them anything in terms of development time. You want the barrier to entry to be extremely, extremely low. All right? Now, why would you want to do all this? Why would you want all this sharing and so on? It's really simple. It's cost savings, right? The less you use, the smaller you are, the better you fit into things. Better use of hardware. So, a little bit of a picture here to help sort of outline what I'm really talking about. What you have on the left-hand side is like the share nothing approach. This is sort of like your private jet approach, right? Everybody gets their own copy of everything. This is typically how we work. There's a lot of laptops open here. You have one machine. It's dedicated to you. You're running typically one thing at a time. You're the only person on the machine, right? You might actually move over to the second one on the left, which is actually you're running multiple. You're running a guest OS potentially on your machine during development, working on deployment and so on. That's fine, right? Typically the things on the left, but this is very, very expensive, right? It's particularly from a customer point of view. What they really want to do is they want to start to move towards the right. And as you can see, as you move to the right, you end up introducing more and more layers of, effectively virtualization, right? Where you end up sharing, OSs, and you're running, multiple app servers on the same OS. Then eventually you're trying to run the same middleware with multiple applications. And then finally, what we're going to be talking about is on the right-hand side, where you're running absolutely everything is exactly one copy. You're sharing everything. Absolutely everything. And at the last possible second, at the highest point in all of this, you have a little bit of state, a little bit of configuration, and that's your tenant. Now, the important thing to note here is that there's a barrier on this diagram between the two tenants, right? And there's a number of very, very key points here. This is hinting at the fact that these two tenants are unaware of one another. So yes, there's a lot of sharing going on. This happens all the time, and people generally know, yes, we're sharing, it's one application, we're running lots of different instances. That's fine. We all know that we're here. In this particular case, you're isolated. One of those tenants does not know that the other one is there. It thinks it has a fully dedicated system. This is very similar to an operating system where you're running on a hypervisor. You think you own the machine. You think you are the machine. You're not, right? This is the same idea moving all the way up the stack. Now, I should say, at this point, before I continue into some of the details of things that we've been exploring, things that we've done, problems that we've encountered, and so on, there are going to be a lot of holes that you're going to spot in this talk. All right? There are a lot of things that you're going to say, geez, what about that? And I will be the first to admit, go ahead and ask, go ahead and point them out. I have no problem with that. And my answer is probably going to be, yeah, you're right. We haven't hit that point yet. We haven't actually solved that problem yet. And we'll solicit feedback on that. The other one is, you might think, God, you guys are crazy, right? Maybe we are, but this is, I don't think it's actually relevant to the conversation that the more sharing you get, the better off that you're going to be. Right? We see this all the time. We have customers with custom applications, custom implementations of these types of things that are actually going out and trying to jam as many tenants in their custom solution as possible. Now, those customers with custom solutions, they're going to get the best bang for buck because it's for their system. What you really want to do is lower the barrier of entry for everybody to be able to achieve the thing on the right-hand side without them having to rewrite any of their code and for it to be completely invisible to them. So really what it comes down to, or boils down to, is that you're trying to do one thing. You've got a hunk of code you're trying to stamp out and run as many copies as possible. So how do you do that? You share. And what are the two real problems that end up occurring by trying to share without, in some sense that none of those applications actually realize that they're sharing? There's two problems, right? Data isolation. So how do you make it so that when you actually have multiple tenants in a single JVM, for example, right, a single application server, that they actually don't end up walking all over one another, that they actually don't realize that there is other tenants around? And the other one is actually controlling resource hogs, right? Whenever you run something typically, when you have an application, it thinks it's the only thing typically, right? How do you actually convince it, without having to rewrite it, that it's not the only thing? And how do you restrict it, and how do you control these things in order to be able to fit as many as possible on, and not having one take over the entire system? And of course, you want to do this without changing the application. Lower the barrier to entry. So first, some building blocks. And I'm going to start basically from the perspective of somebody deploying an application and what they want it to look like. And this isn't fiction. This is stuff that we've actually built. And again, I want to say that this is the current path that we're on, and not necessarily the golden path per se, but it's just really pursuing various ideas. Now, the first thing is that it starts right at the command line. Right? You do not want deploying an application to look much different, if at all, from deploying a regular application. So starting point, just add a new command line option, right? -xmt, multi-tenancy. And that's actually the opt-in to say, okay, yes, from an ops point of view, when I'm deploying this, I understand I'm going multi-tenancy, but the app, I'm not going to make any changes. It's just going to get deployed to the cloud, right? The multi-tenant host. So the app, this is truly like a nice split, right? Your ops is saying, yes, okay, fine, we're going to make it, deploy it to a multi-tenant environment. The developers didn't change their code. They're still writing as if it's a single tenant and so on. And it looks and smells exactly like a dedicated tenant. The benefits to start with here, right, are obviously that you're running a single JVM, hopefully, right? That's less duplication in terms of the code, less duplication in terms of the effort. You're sharing the results and the benefits of the JIT, the GC, and so on. And hopefully, especially if you've already got a multi-tenant host running, then you've actually got really fast startup. You want to stamp out another copy and run it? Super quick, right? Initialization is already done, your VM's up and running, threads are forked, et cetera, et cetera. Let's just go. So what does this actually look like? And I want to run through this pretty quickly. So the first thing is that, okay, I want to deploy something. I type my java-xmt, specify my jar file, look, go. All right, it's a very simple example, obviously. So the first thing that happens is that the executable says, okay, hold on, you're multi-tenant. So what it's going to do is it's going to go out and it's going to look and say, look, is the multi-tenant Java host actually running? Do we actually have one out there or not? If not, it says, okay, fine, we need to start one up. And of course, the first one is always the slowest. It has to bring up a JVM, start out the application infrastructure, get everything going, initialization and so on. And then it says, okay, fine, I'm ready to go. At that point, you end up pushing across effectively the jar file and saying, all right, here's your application that you're going to run. Right? Now, the host is going to take a look and say, okay, it's this particular jar file. Do I already have that loaded? Do I already have these classes loaded in the system? Yes, no, yes, okay, fine, I'm just going to use them and don't worry about it, right? It's really kind of a class sharing solution, if you will. If not, it'll load up the jar files, do all the necessary initialization, and then get things going, right? Now, this thing's off and running and hopefully warming up the system and doing lots of interesting things. Now, what can happen here is that somebody else comes along and runs the same command line option and says, oh, that jar is actually already on the command. Sorry, I've already loaded that application, so I'm not going to load it again. We're already mostly initialized, and it'll come on and be able to just run that code a second time. But what can also happen, and the diagram I had with all the different versions of the system with various sharing and so on sort of hinted at this a little bit, and I did talk about it earlier, is that you can actually come along and say, well, look, I want to actually run a different application, but I want to share a lot of the same infrastructure. I want to share a lot of the same data. I don't want to be taking full footprint. compared to what would happen is if I ran my own dedicated JVM and own dedicated app server again, for example. So it says, fine, here's my jar, here's my application. The host says, okay, I don't have that one. It's going to load that copy in, right? Perform all its initialization as necessary, and run it, right? Now the key here, right? And there's a lot of details. We're going to cover some of the details, in the internals of how this works, because I'm sure a lot of people are thinking, well, what about statics? What about constable entries? What about customization, locales, and so on? There's nodding in the front. You guys are crazy, right? Yes, I know that. So we're going to get to that. But how do you handle these things, and how do you make them fairly transparent? Because it's easy to say, well, look, I'll load this in and one copy, but just talk. All right, I'm loud. Okay. Right. So anyways, you want this whole thing to be absolutely transparent to the actual jar. All right. What else do you need? Right? Some very basic things. These are things that you would just know. I mean, you look at the system as a room full of smart people. Everybody here is going to understand this. The first thing is that your core infrastructure, your application server in this particular case, as I keep kind of going back to, that's actually a tenant in and of itself. There's sort of a global economy that goes on between all of the different tenants. You can think about global data structures, caches and so on that exist within the main application server that's running as the host. This thing is this thing participates in it, right? It's also using the heap. It's also using resources on your system. So you need a way to be able to talk about it, and a way to restrict that as well. Now, your application server, which is actually shared, is going to need customization, right? We're not saying that you're not going to have any customization anywhere in your stack. What we are saying is that you're going to have customization at the application server layer and down. Okay, so all of your infrastructure, all your middleware and everything, that's going to have to be aware. All right, and part of that is going to be understanding the resource management and so on. All right, so this is a bit of a sticking point for some people, but the point is that for somebody actually showing up with their war file or something like that, it just works. All right. Okay. All right. The other obvious thing, and look, if you've been in the runtime business for any length of time, you've probably invented these types of isolation systems and identity systems and so on at least twice. I know I've been through it myself at tons of times. If you've worked in the embedded space, you've definitely done things like this, no doubt. But one of the things you need to do is, within the Java application, you need to be able to identify things, right? You need to be able to say that objects belong to this tenant, classes were loaded are used by these tenants, right? Again, this goes back to data isolation, right? Are you allowed to see this data? Are you allowed to see this item in the cache or not? Are you touching the right things? What do you belong to? Resource management as well. Are you allowed to actually allocate that much memory? More, less, what have you? Differentiating between tenants as well. Think from a debugging point of view, right? What does this mean? Somebody ran out of memory. Well, who, right? Who ran the system out of memory? Worse, some database query was off. Well, which tenant actually fired that query off, right? Who actually did that? Right? Interesting points, or things that you need to be able to identify. And also things like state too. How much free memory does your tenant have? So here's one of the big ones, right? And this comes down to initialization and having kind of this global resource, or this kind of unified master tenant issue of you've got a bunch of classes that are actually shared by a bunch of different tenants, and they're not supposed to know about one another or affect one another. And this is really the sticking point, right, for a lot of people. So there's a bit of sarcasm in the slide. Static variables are bad for sharing these, but the point is that every library's got like billions of static variables, right? We always tell developers when they're joining the JVM team, for example, don't use global variables. Set the rule, don't use global variables. It means you're always going to get a couple, right? That's why you never say you go ahead and use global variables, because you're just, it's just crazy. Either way, there are global variables. There is shared state. What do you do, right? How do you actually make it so that it doesn't look the same? This is a kind of a very simple example, but it's one that's actually pretty effective, right? You've got a locale. I'm Canadian, if you hadn't guessed, and you actually want to set what your default locale is. Well, that actually might be different for some tenants versus others, right? But you've only got one static variable, so who wins? The first guy? That doesn't count. That's not good. That's not a solution at all, right? You want a way so that each tenant has its own perspective on things like static variables. And this is just an example, right? Statics are like the obvious one. But you want each tenant to have its own perspective on things. So how would you do this? Well, I think John Rose said, as soon as you mention the word class loaders, you know that it's wrong. Yesterday, I'm not gonna go that far, but I'm gonna use it. You could maybe try to do something with the usual class loader tricks, right? Load each tenant, gets its own class loader. I think that's kind of obvious, but and this is great, right? I mean, each tenant, okay, fine, you stamp out a copy, you load the jar, fine, create a new class loader, new classes, and so on. But you've gone and undone the exact things that we're trying to do, right? Now there's plenty of duplication. Now this class is all over the place. You've got the same class that you're running possibly 1,000 times, right? Duplicate it. Now you might be able to eliminate this with some JVM class sharing or so on, but we're also talking about JITted code again. There might be some ways to AOT it or have the JIT actually understand, yes, it's the same thing, unify it, but it gets to be a real problem. The other thing is that it's fine that you separated all the statics, but there might actually be some statics that you actually want to share, okay? There's a lot of duplication, especially if two tenants actually instantiate the exact same thing and it's immutable. Why wouldn't you share that, right? That's the whole point. We're trying to share. Right? Even worse, though, is that we haven't actually solved the problem, right? Master tenant is likely to contain a lot of these things, like locale settings and so on, or something similar. Really depends how things are architected in your system. But you're still left with a single copy. Right? And so what are you going to do? You're going to push everything, including your base class libraries, all the way up into individual class loaders? Probably not. All right, let's try and be smarter, right? Let's rewrite the bytecodes. Yeah. Right? A lot of people in this room are really used to just generating their own bytecode, so no big deal, right? Rewriting. Right? Well, yeah, right? It's just whatever. Every time somebody refers to a static, okay, fine, we'll change it, right? We'll develop some structure and we'll say, okay, well, for every static variable, we'll map it to some array or something like that, or every tenant context will actually have an internal array to say, here's all my statics that I have to create some level of sharing. And then you might, at each static reference point, it gets really easy. You say, okay, well, maybe it's some property style referencing. Please give me this class's static and so on. You can do things like that. Right? You can actually build something like this, but there's tons of errors, right? You're potentially, causing class loading, ordering problems with some of the pre-lookups that you have to do and so on. There's still issues like JNI. You haven't affected the JVM. It's great that you rewrote bytecodes, but what does JNI do, right? What does reflection do? Same idea, right? What if you have other bytecode rewriters in your system? Oops, right? Hopefully the last one, right? Or make sure you're the last one, but one guy gets to be last, right? So. But we are pushing towards the right answer here, okay? So this is, it's getting close, all right, in terms of what we want. But really all that this says is that, look, there are lots of different solutions, but you need to actually drive this down into the runtime, okay? So, the approach that we've taken is actually to really shove it down into the runtime and let us handle it, and really just using an annotation on the fields to be able to specify, look, this is something that I want to share. All right. Now, you may actually say, well, hold on, Ryan. You just said you don't want to modify any code in these tenants that you're deploying, and you just changed the code. And what I'm going to say is, okay, there's two levels here. The first is that in your middleware, you are going to change your code. I've already talked about that. So you can actually look at it and say, okay, fine, I'm going to make some changes here. Sharing and so on goes on at this point. No sharing at this one. And you have to make those types of decisions at that point. At the tenant layer, when you're actually deploying a tenant, everything is just marked as tenant scope. Okay? So there's absolutely no sharing between the tenants. All tenants are basically get their own copies of their own statics. All right? The interesting point here is that there's the potential, of course, to opt in if you really do want to modify your code, but we're trying to stay away from that. So every tenant gets its own copy of its own statics, but anything at the middleware and below, it's at the choice of, you architect it to that point, all right? And you actually do some interesting things too. If 90% is actually using Canada as locale, you can actually use just like one instance if you want. In this example, so it's kind of a poor example, but hopefully it illustrates the point. So I've already talked about this a little bit, right? And the point here is that, again, you're loading, things are taken care of for you in the runtime, and this is one of the things that we really had to push on and actually get mostly right, is the ability to basically say, look, it's just transparent statics, you each get your own copy, but then getting the middleware to change its infrastructure, that's really the sticking point. right? That's, there's still problems here. There's still a hole. All right. Last building block. I'm an ex-GC guy. You can't have a talk without at least one GC slide, no matter what you're talking about. And we mentioned IBM's region-based GC technology here, which is called Balance. Some of you may have heard of it. Roughly equivalent one from the hotspot point of view is G1. Okay, there are some differences, but ultimately, the real point here is that from a tenant point of view, you're trying to restrict resources, so memory usage. You're also trying to be able to say, well, look, what objects belong to what tenant? You want that to be very easy to do. There's definitely a lot of solutions out there that do things like, say, map in a new variable name, or sorry, a new slot into every single object so that it actually has its tenant context pointer backwards. You can do things like that, but that's a little crazy, in terms of the footprint and so on. We're trying to make things smaller, not bigger. So, why not leverage some of the existing tools and facilities that we already have? And so in this case, we have a region-based collector, which basically means the entire heap is carved up into evenly sized chunks. And as a new tenant is deployed, we say, okay, look, you get the following number of regions, that's fine. You're restricted, you can only allocate into those particular regions. If you need more, if we have more available, we may give them to you, but it's very easy for us to pull memory back and hand memory out. It's also very easy for us to be able to say, well, how much memory are you consuming, right? From a garbage collection point of view. It's very easy for us to take things like data that's maybe allocated in the tenant scope and then push to the more global master tenant scope and actually move that data very easily, right? It's very easy to sort of pick that up and go, oh, you belong here, we're going to move you over here and make you part of the system as a whole, right? And kind of move your costs from you to everyone. There are a few details here. Finalization needs to run in the proper context. You might say, what's finalization? Who cares? And being a GC guy, let me just say about finalization. Some knowing laughs out there, or chuckles at least, anyways. It's more than just being able to run finalization, right? You have to. The finalizer thread, if you want to take it in kind of a very basic sense, has to join a context, say, okay, fine, I'm going to allocate in your space now, and then run its finalization. Because finalizers can allocate objects, right? You'd prefer that they don't, but sometimes they do. And this can be a real problem because it ends up holding up other tenants' ability to finalize, which maybe holds up tenants' ability to collect garbage quicker, and so on. And there's also the usual aspects about cost of garbage collection, who's costing you more, who's allocating more frequently, and who's actually just larger, and so on. And the final one, the final point at the bottom of the slide here, GC read-write barriers. You might actually ask, okay, well, what about security? What if you got multiple tenants and you don't want them to access each other's data? We haven't actually crossed this line yet in our own investigation, but something like the region-based approach, right, to GC lends itself really well to being able to say, you're an object here, and I'm going to refer to some other object that's in a different tenant, right? You can slap them on the wrist and say, that's it, no, right? Throw an exception or something like that. It's really easy for us to do that if you've got everything nice and walled off and you're able to say, this belongs here very quickly, right? Obvious stuff. All right, so that's it, right? Basic blocks, that's it, we're done, right? We're done. Problem solved, multi-tenancy, run out and get it at a store near you. Right? We're done. Hardly. That was the easy part. The point about the multi-tenant approach is actually your resources are valuable, right? There's a lot of MacBooks here, right? Those things are expensive, right? Everything in them is expensive. I mean, everything counts, right? So think about bigger and bigger machines, right? Your memory, it's expensive. You want to guard it, right? You don't want, if you've got 100 tenants in a system, you don't want one abusing all the memory and taking it away from everybody else. Same with processing power, right? I/O is a huge one. Nobody ever thinks about I/O. People, when they think about a JVM, they think about memory and CPU usage. They always forget about I/O. I/O is hugely important, right, from guarding that. Pardon me?
File is always running out.
Yeah, well, there you go, right? So maybe this is a bit counter to what was said earlier or yesterday, where disk is cheaper, but it's still valuable, right? And it's very easy for one tenant to actually just sort of run away and cause you huge problems. So you've got to protect yourself. You have to protect yourself. As the runtime, it's your job to protect not only yourself, the runtime, and the system as a whole, but actually protect each individual tenant from one another. So I'm sure at every, some point in everybody's life, we've been on both sides of the fence here on this one. And really the message here is that, I've talked about protecting yourself and so on, you have to be careful. I'm not even talking about malicious code here, all right? We've all just written code that's just run away on us, right? And don't attribute, to malice what can easily be attributed to ignorance, right? And these are the type, you just have to protect yourself. Doesn't matter how smart you are, how safe your system is, things can go wrong inadvertently, right? And causing much more work for everybody else. All right. So let's talk about memory, right? One of the sayings I like to say, and not everybody agrees with it, but Java is memory, and that's kind of a problem, right? Everybody forgets about it, right? There's always this thing about, well, garbage collection is really, the illusion of infinite memory, right? That's one way that you can sort of put it. And, because all we do is we just allocate and we let the garbage collector kind of clean things up. And this ends up being a problem, of course, because nobody really thinks about it. And there's tons of issues with memory. Memory is one of the leading problems that we have with multi-tenancy, right? It isn't a matter of CPU time. Now that actually does come into play. But memory ends up being a real blocker in the sense that you get up enough JVMs and that's the end of it, right? You've got tons of CPU left over, but you don't have enough memory to load yet another JVM. So, one of the things with actually tracking a tenant, making sure it's not doing too much, is making sure that sharing and consumption is actually happening properly. So this is everything to the levels of contribution of global data. So when you're actually looking at a global cache and you add an item to it, I mean, should you be billed for that, or are you actually moving it to the global economy, right? What if nobody ever uses it? What if you're populating a global cache, right, and you think this is a good thing, and yet nobody else uses this? So how do you actually count that? Do you count that by lookup, right? Is it 0, 1, and many? You insert it's still yours until somebody else looks it up, and it's like, okay, fine, everybody gets billed now, and you just spread the costs across. There's problems with implicit versus explicit data creation. String constants, the obvious one, right? You're the first one to run a piece of code. Is that your fault? You just got there first, right? The other thing too is, the growth of data structures. I've already talked about that a little bit. One of the hardest things is, what does system-free memory mean, right? Remember, tenants aren't supposed to really know about one another. They think they're the only ones. When you say system-free memory, what does that mean? Right? Is that your tenant plus the master tenant? Total free memory? Well, you don't really have all of that free memory in the master tenant. So what do those types of things mean, right? How do you actually, and we have systems that actually call system GC, right? Because they think, oh, I'm running out of free memory. And you end up affecting everybody else. So, things like configuration as well. Somebody deploys an application, they specify -xmx. What does that mean? Right? What does that mean now in your multi-tenant environment, right? Okay, well, do you start splitting the cost? I mean, you sort of have to make guesses up front, really, right? Until you actually know the system. Right? It's kind of interesting because a warm system, as we start to warm it up, we start to realize, this tenant typically takes this amount, right? And GCs this frequently. So the next time we create a copy, we're going to give it that much, right? And unfortunately, you sometimes end up over-provisioning a little bit, just like you would with a normal VM deploy, right? In order to make sure that you're actually going to be able to fit things in. And of course, we talked about the last points as well, garbage collection, finalization. Where does that billing go, right? If you finalize something, you were the last one to use it. It was in the global economy, but then you're the last one to hold on to it. Should you be paying for that? Does everybody pay for it? If you're putting a lot of finalization on the queue, you're blocking everybody else. Do you start paying for other people's garbage? Tough questions. So that leads us to, what do you do with bad behavior, right? What happens when something goes wrong on your system, right? Control C, kill 9, right? Task manager, end process. Cycle the power on your machine for some OSs, right? It's really easy to do, right? Getting the hypervisor, just say, yeah, fine, we're going to recycle that instance, bring it back up again. Super quick, no problem, we don't have to think about it. These things are built for that. The JVM, absolutely not. I had this conversation with John last night about thread stop, and I mean, it's just basically a non-starter. I mean, ignore the deprecation and so on. But one call to thread stop, and you're talking about an inconsistent data structures throughout the JVM, right? Potentially. You can even put in safe points, but it's just not good enough. It's just really not good enough. You have to really, really program to that. And the worst case scenario is one tenant crashes, right? You're in a single deploy, it's fine. One tenant crashes, that's a JVM, that's fine, whatever. Everybody else is still running, not an issue. One JVM crashes, they all go down in flames. When I say crash, I don't mean a stack trace, right? I mean the JVM drops core and that's the end of it, right? You running 1,000 tenants, oh boy, that's it. That is it. So when you're deploying, I mean, this is actually an ops problem, this last one, is you have to look at it and go, well, what are the high value tenants? And you might have to run those individually. But there's a lot of non-high value tenants. There are a ton, a lot more than the high value ones, right? And especially when you start to think about state, right, being held potentially in, in data grids and so on. It's the kind of thing where you're actually running with almost virtually no state or no valuable state at any particular time, right? And if you happen to crash and go down in flames, that's fine. Somebody else will pick it up, right? One of the other billion other tenants that you've got out there will pick it up. But anyways, the whole point is that you can't stop things, right? So instead, you've got to consider actually throttling it, right? If you've got something bad going on in your system, run away, it's using too much memory and whatnot, you can't kill it. I mean, the ability to kill things within the JVM is we're not built for that. So instead, you start to throttle it. Stop it from allocating. Next time it allocates an object, forget it. No, right? You have to maybe continue to allow it to work until it ends up coming outside of a synchronized block or something like that in order to allow other tenants to move forward. That's okay, but once you get there, stop it, throttle it, really slow it down, right? And then maybe you can recycle the JVM. So how do you solve these problems? Now, I'm not going to tell you that 284 is necessarily the answer, right? But it's a really, really interesting building block for you, okay? And this really points to the need from the runtime system to have a better interface to the platforms that it's running on top of. And when I say platform, I mean the OS and I mean the hypervisor, all right? One thing that we really haven't done, there's a lot of various toolkits and so on, beans that you can sort of introspect and whatnot, but the real problem here is that the JVM sort of spent way too long in some cases hiding the platform from you. And we have to not necessarily bring it up and all become low-level programmers, but awareness of these types of things is going to be really, really important. Okay? And the ability to sort of be able to configure this kind of stuff and talk to it and say, well, look, I need this managed a little bit better is important. And the reason why is that if you actually try to do this just from the runtime, you can do a reasonably good job, but not necessarily a perfect one. So what I've got here, and I just want to do this really quickly because I'm basically running out of time, is we wrote like a really simple application, and we said, look, what we want to do is we want to configure this and say we're going to limit this app to only be using 30% of the CPU, and we're going to run it again and say, look, only use 60%, and see what kind of accuracy we end up getting. And we ran two different flavors of it. One was actually using an OS workload deployer, manager, and so on, actually making sure that we can restrict usage. And one is we actually tried to do it internally in the runtime, right? Now, so that's, left is the OS, right is the runtime, right? Now, this was a very simple experiment. You can actually see, the runtime wasn't terrible. You can actually tell that there's a difference here. And you might even, if you squint a little bit or you stand far enough, back of the room, you might actually claim, yeah, I got 30 and 60%-ish. But it's nowhere close to the same accuracy that the operating system's going to get, right? And I don't think you're ever going to really get there unless you're actually talking to it, right, at that level, right, and actually really cooperating with it. So from the runtime, I mean, if we're going to push these things down into the runtime, I mean, that's pushing it all the way through, right, and making sure that we operate as one cohesive unit, right? And, from some people's perspective, we are an operating system. Right or wrong, we have to be able to provide these type of facilities, particularly when it's from tenant to tenant, right? One's 30%, one's 60%. Right? They're not all going to be the same. This is a process level thing. All right, one last one before I call it quits. Excuse me. Statics again. Right? Coming from IBM, we've got a lot of legacy hardware, legacy products, legacy things that just a lot of customers use, right? And anything from hardware accelerators to platform facilities and so on, they end up calling out to native libraries and making use of some accelerator or facility that comes back to the JVM. There's a bit of marshalling and so on, but whatever, it does a really good job at whatever it's trying to do. The problem is that you end up using a shared library to get there, and this ends up being a real issue if there's shared state, statics, or what have you out there. Two tenants calling to the same natives are going to end up sharing that state, and that's exactly what we're trying to avoid by splitting the statics earlier. So we could do things like rewrite the libraries, right? But this is basically a non-starter, right? It's what we're trying to avoid. We don't want to be rewriting stuff. The other thing is that plenty of people have actually lost the code anyways, and they've got these binaries. They don't have access to the source code, right? They can't rewrite it, so you're stuck with it. So and this isn't anything new, but I want to return to the idea of, one of my earlier charts where the runtime was actually, forking another process as the Java, multi-tenant host, and build on that and actually say, okay, well, what if we actually build like a proxy call situation where you actually load up the shared library in some lightweight processes, we don't share the statics or anything like that in each one, and that's how you get basically per tenant scope. You might be like, holy cow, man, that's like a new process. Right? Isn't that really heavyweight? Well, not necessarily, especially given the size of the JVM typically, right? Heap and so on, and what's going on there. It is an approach, right? It is something that we use. There are some interesting possibilities with this as well. You don't necessarily have to have the shared library be on the same platform as your multi-tenant host, right? Actually, be a completely different architecture if you really want. So there's some interesting possibilities there. Some interesting kill possibilities as well, if you like, right? Kill 9. I mean, you can actually, drop one of these processes. Now, what that ends up meaning for the actual Java, tenant running, okay. But it's kind of interesting. You actually control-C these things and actually kill them and say, look, you're done, right? And sort of get that out of the way. Again, what that does from a kill semantics point of view, interesting. And of course, latency is the big problem. So there are tons of other things, right? In conclusion, or not even conclusion, but what's next? I think the last few charts, really, really speak to the fact that we need to start, pushing our connections, pushing the facilities downwards into the runtime. You have to make this fairly, transparent's the wrong word, invisible or opaque to people deploying things, right? I mean, they don't want to rewrite their code. There's a lot of stuff out there. There's a lot of frameworks and so on. You really want to build strong walls too. There's, I didn't cover it, but there's still things like locking, right? Do you still want to spin in your runtime? Locking from the global sense of that may have been okay when you only had 2 or 3 threads running in your tenant when you were running on a single JVM. But what if, now you're talking about hundreds of tenants, that's hundreds of threads hitting the same lock, right? Do you end up having to do things like, a tenant locking scope versus a global locking scope, right? When you synchronize on a class, what does that mean, right? If you're a tenant, maybe each tenant gets to synchronize on its own monitor kind of thing, right? If it's a tenant class. But if it's a global class, well, that's going to cause you problems. So we want to really build strong walls, right? And this is just sort of the tip of the iceberg on things. There's a lot of big wins to be found. I want you to just think about it. If you're able to run 10 instances in the same size that you're able to run 1 instance of JVM, that's a huge, huge win. Right? And we're talking about hundreds, if not thousands. Right? Each one of these charts, and I've actually skipped a number here, we could go on for days about. But anyways.